Good morning, ECOS line team. Welcome again to another ECOS Let Your Culture of Safety, Lineman Safety National Webinar. This will be number 042 with my buddy and your friend, Mr. Danny Rains with Rains Safety Solutions. This is a special time, at least for me personally, because 3 Februaries ago, this is March 2024, 3 Februaries ago, Mr. Danny Rains was the gentleman that came in here and kicked off. He launched Electric Culture of Safety with his 002 electric system grounding. And I suggest you all get that copy of that recording for your line team. And what was interesting is several months before that, I spoke with Danny and some folks from ISPC, the Incident Prevention Convention, conference, safety conference, and spoke with them. And I said, look, folks, I said, I got this idea and I want to get together and do these Lineman Safety National webinars together. And you guys need to come to South Carolina, which that's where we're here today, and share. Your company's going to pay for it. You're going to pay for it. Beer will help pay for it. Beer meters in our Liveline Training Center here. And we're going to do it together. We're going to form a team. We're going to collaborate. We're going to form a network. And we're going to come together and be unified. No more walls. No more division. No more isolation. And we're going to talk. We're going to get together and talk and share your experience. And Mr. Danny Rains, he was the first one. Said, hey, I'm doing it. Danny came here yesterday and we didn't pay him. You all didn't pay him. He paid for it. And it's amazing what we're doing together as a line team. And I want to thank Danny and appreciate everything, my friend.
Yes, sir.
Okay, appreciate everything. And so Danny, what's the difference between you coming here now today from when that February? What do you remember the circumstances?
If you could see, the cameras could see the pretty blue sky behind us, it would be wonderful. But the day I was here 3 years ago in February, it was coming a storm. If you look at that ECOS 002 recording, you'll see the flaps of the tent was shaking, and we were watching, hoping the whole thing didn't collapse on top of us. It was an interesting day, but yes, this is a beautiful day that the good Lord has given us, and we're going to take advantage of it today.
Yeah, so it's neat. It's so fitting. From then, it's like sometimes we go through life and we want to make a change in our life and we want to do something different, and things happen that try to prevent that from happening, like that first ECOS episode 002 with Danny. It's like, it's like the weather just did not want this to happen. And like a resistance to this movement, right? This culture, this new way of thinking. And it's just neat how it has developed, Danny. And I just thank you, man, for coming here.
It's my pleasure.
So why? Tell us why you decided to volunteer, basically, and give back to this cause of all of us.
Well, I've dedicated most of my life since I became a lineman and then a trainer, but to share my experiences with the industry and what's going on in the industry now with all the new folks coming in, and you know, the old folks like Rains here, we're leaving. We can't do it anymore. But we can still share what we've learned over time. And that's what I've kind of dedicated the remainder of my life to. I'm still doing it now, and I'm too old to be doing it. But I'm still out here shaking the bushes a little bit, sharing what I've learned. And it's just like what's in the book there. And I think he's going to talk about my book about Legends of an Old Lineman. But you'll see if you ever read that book, things I learned that worked and things that didn't work so well. Mm-hmm. And of course, I'm still here, you know, got all my fingers and toes, and I did good, learned a lot along the way, and that's all I'm doing is sharing what I've learned.
Mm-hmm. It's neat. So I recommend you all getting this book. reading this book and going through Danny's experiences, it will help you reflect on your experiences. In other words, how I want you to relate what Danny wrote about his life as a lineman. I want you to read these words and look inside. How did what Danny, his experience, how do they relate to your experiences? And what I mean by that is when you read this book and you see Danny here today and what he's doing, the influence and the significance of what he's sharing is in his heart, which he shares, and his mind, which he shares in our industry. It is so important that you recognize all these chapters and these experiences and reflect on your own life, because what happens, your decisions that you made will cause you to see forward. You can actually look forward and how do you want your life to be when you're close to retirement? Danny could retire, but he's not retired, all right? So think about what you want your life to be. And here's the deal. I actually titled you, Danny, you don't know this yet.
Really?
I titled you. I gave you a title. I'm doing that to the speakers of ECOS.
Oh, okay.
Your title is The Georgia Line Legacy.
Oh my God.
That's Danny's title, okay? But go through his book. So Danny, tell us a little bit about the structure and how this book flowed from you to us.
Well, you'll see as I present a little bit today, if you hadn't already, some of you's probably already heard my presentations or something that I've done, but I teach by illustration and storytelling, and I feel like that's the best. I'm going to share my experiences. You know, I'm going to tell you what I found out it will not work. Don't try that. But after so many years of teaching and instructing, you know, I've had a lot of people come up and tell me, so, well, Dan, why don't you write a book? And I said, well, never thought about that, but I will. And I did. And I started writing a couple of years ago, and it was published December a year ago.
Yeah.
And it starts at the time when I first went to work at Georgia Power Company as a 19-year-old kid right out of high school. And from that point on, you know, that's when I started learning. You know, I didn't know a whole lot, didn't know anything about the utility industry at all. And, you know, after 40 years of it, and 20 years of it as a lineman, and the rest of it as supervisor and trainer, safety, I had felt like I had learned a lot, and I wanted to share it with people in the industry that's coming along. If I can prevent you from doing something stupid and getting hurt, that's what I'm about.
That's awesome. Well, Danny, appreciate you coming here, brother.
Certainly, it's my pleasure.
Appreciate you coming again for number 2, your second visit.
Wow.
And it's just a blessing to have Danny here. Spent some time with him and Miss Pam Tompkins last night over dinner, and discussing things, discussing the past, discussing, you know, reflecting on the past and looking into the future last night, and some things that need to be changed, and what are we doing about being the change and living the change. And this is all what we're doing here today is all part of this. And Danny, thank you for giving back and being that line legacy from Georgia. Okay, thank you, brother.
My pleasure. Well, all right. Well, thank you so much for your kind words, Brent. I appreciate it. It's really good to be back in South Carolina again. It seemed like I was just here yesterday, the day before. It's amazing how time flies when you get a little age on you, or a lot of age on you. But for those of you who do not know me, I'll kind of give you a little snippet here, a presentation of me. I retired from Georgia Power after 40 years. So I did retire once, it just didn't work. I failed miserably at retirement. So I started my own company at the request of a lot of people I'd met through the industry, through IOTA and, you know, Inter-Utility Overhead Training Association and Incident Prevention. And they said, well, Danny, why don't you come speak with us? And I said, well, if I'm gonna do that, I gotta have a company. So I set up a LLC and I started, and we've been traveling all 50 states, had several people, 1099 contractors working for us, and been sharing education, what we've learned. Every one of us very passionate about safety and about, you know, not getting hurt. They told me a lot of stuff when I went to work at Georgia Power when I was 19 years old. One of them, I never will forget, one of them, you don't get hurt every once in a while, you ain't doing nothing. And I said, huh? What are you saying? I got to get hurt to work here? What do you mean? No, that ain't the case. He said, now if you just keep working, but that ain't the case. We can do all this stuff and we don't need to get hurt. Well, when I retired, the OSHA Outreach Center at Georgia Tech asked me to do the 1910-269 standard. So I developed a standard in a PowerPoint, and I share that there whenever they request me to do it, or they send me off sometimes. And I also do that for my customers too. As a result of that, I started doing e-hazard work with Hugh Hoagland before he retired. And I'm an affiliate instructor there at e-hazard, and I do the NFPA 70E arc flash training. You can see 56 years. I hope you can see the slide. 56 years, and I was kidding with Brent earlier. He says, 56 years? I said, yeah, I started when I was 3 years old. No, not really, but still, it is what it is. I did write the book as a result of all the traveling and meeting people and talking with them, and I really like that. And that next to the last bullet point right there is one of the most sensitive things that if I've mentioned today, and I probably will as we go through this, because lack of cover-up, poor cover-up, is a result of many of my subject matter expert requests by attorneys to represent, and I usually, I represent the defendant for the most part. Unfortunately, it is us, the linemen, that usually is the problem, that we cause the accident, or we fail to follow regulation, whatever it takes. I can begin to tell you, I've had 25 cases probably. In just about every one of those cases, as a result, a mistake was made on the work site. Either a poor job briefing or a hazard that was not identified. There was something that went wrong. But because of all of those terrible things I've seen happen to people, the linemen, that's one of the reasons I share this today with you in an effort to educate you to keep that from happening to you, because it does not need to happen, God forbid. And there is a picture or two in here that might be very disturbing. I'll go ahead and put you on notice there that if you see a picture in here that looks a little disturbing, it came from Joseph M. Steele Burn Center in Augusta, Georgia, which is one of the premier burn centers east of the Mississippi in the United States. But you might see. Last thing on there, team member program of the CUSP program, me and Pam Tompkins, we talked about it a little bit last night, and there's several of us got together at Carla. Basically, she said we need to come up with a CUSP program, and it all started around a dinner table in Denver, Colorado, about 2004, I think. And it was a result of the CUSA program failing. So now we have the Certified Utility Safety Professional program out there that's an ANSI recognized certified accreditation for those of you who choose to go down that safety or operational mode in your future. It's it's one of the best things that's ever happened to the industry. We basically all agree that it just every company needs a CUSP. If you got a safety director or an operations director or whatever you've got, they need to be at the level of competence that they can interpret regulations and understand the industry, have constant contact with the industry, see what changes is coming, all of the things that's going on out there. Because believe me, it changes every day. So with that, I think I'm gonna get started with the distribution cover-up. There's one of my polls a long time. No, not really. Like I said, I kid around a lot. I have to have a little humor in here because it's gonna get real serious in a minute, okay? But yeah, you look at that, that's about 1948. That's about the year I was born right there is when that picture was taken. And then, you know, you look at today's world, do you see how much rubber? And I show this to some of my customers when I'm doing this cover-up program, and they say, well, my God, is it 2 trucks that brings all this stuff out here or what? Well, that's a little bit to the extreme, but let me tell you something. Here's what I normally see. This is what I normally see. And this was the mistake that my company made for years and years, thinking, well, we did do a good job of cover-up. We did do a good job of cover-up. But over time, things were still happening. And you'll see the numbers in just a few minutes. Take a good look at that. That cover-up is typical or even more than typical of what I see. I had a friend of mine named Vince Bond the other day call me, and of course Vince and I have been working around Georgia Transmission for years, and he works for Sylvie Construction now at another company. But he was driving through a municipal in Georgia, and you know us safety guys, we're gonna be looking up. We don't never watch where we're going early on the road. He looked up and he saw this guy changing this pole out, and you know he had about 3-phase pole. And he had set a new pole, and he was transferring the conductors. And you know, he looked up there, and he didn't have enough rubber up there for nothing. He was tying in a phase and didn't even have a split blanket around the pin insulator or pole top pin, whatever. He turned around and went back and talked to it. Now here's the problem. And not that I know it all, because I don't, but God, have I learned a lot, okay? Vince asked him, said, well, why don't you have a little bit more rubber? He said, I don't need it. I said, really? He said, really? He said, yeah. He said, well, shouldn't you have a split blanket around that pole top pin where you're tying that phase in right there, tie wire, get loose, whatever? I know line work. I don't need any more rubber. If you need more rubber, you need to learn line work. And I'm going, holy crap. And Vince just went phase to ground. He just said, I just, you know, never. But you're going to see another situation in here just to kind of, you know, just to kind of support what we're saying right here, is that the opinions that sometimes we hold is what gets us in trouble. Let's look at what I call energized distribution cover-up and gloving work methods. I carry this program around all over the country and put it on from Hawaii to Alaska to Maine to Miami. And you know, line work's line work. There's only one thing we got in common. The big end of the pole goes in the ground everywhere I go, but everywhere else, it depends on system and beliefs and operations and everything else. Whether you got a Y, Delta system, it doesn't matter. You look at everything. But line work and cover-up doesn't change. I don't care where you go, okay? What's important about it? Well, EPRI and NIOSH did a little homework years ago, back in the late 90s up to the early 2000s, and this is what they found. The average death of a line worker was 25 to 34 years old. And you know, that's the most likely age group to get involved. Now, you figure after you've been doing this about 10 years, you know enough to, you know, to stay out of trouble. And it don't happen. It's most of the time, you know, if I look at the cases I've had, you'd be surprised. Now, there is a trend toward younger linemen getting injured now. That's a fact, okay? But some of the ones that really was ugly was 15, 20-year linemen, which doesn't make sense. That doesn't compute to me. It's like another one of those old sayings they said at Georgia Power when I went to work there. If you ain't been here 10 years, you're a liability. But after you've been working for 10 years, you usually made lineman in 4, then you can or may become an asset. Well, lo and behold. And I said, well, wait a minute. May or can be an asset? It depends on what you've learned and how you've learned to work. Oh, that makes sense. So let's look and see what's going on. Here's that study that they did 24 to 28 a year, and that's a 10-year running average. And that was back in, the, like I say, the 90s up to mid 2000s. And when you look at it, what's happened since? Well, 2017 around 26, and then 29 and 18, 39 and 19, 26 and 20, 21 had about 30. There was some, I think there was some controversy there, and I'm not sure exactly. Now, most of these fatalities right here are on voltage, okay? And then in 22, the last I heard was 31. I don't know. I've lost track. Now, I don't have 23s. It usually takes a while for all the dust to settle, and whatever happens, it happens. But look at this number. This thing bothers me right here. You add all that up, it's about 181 fatalities over a period of 312 weeks, okay? That averages 1.7 linemen or apprentices die a week. That shouldn't happen. I've seen too much grief. I've seen too much things happen, especially in these civil cases and OSHA cases that I've been working with for the last 15 years, 20 years. Well, David McPeak's hierarchy of controls, we turned that thing upside down and put PPE. It was on the bottom before, but it looked like the foundation of safety, but that's not the case. When you look at the hierarchy of controls, the engineering, elimination is the best. If you could lock it out and tag it out every time we work on something, that'd be great, but they could have a bunch of Boy Scouts out here doing this and not linemen if we could. So, all the engineering, got great engineering right now. They got great designs, IEEE's out there working daily. You look at Schweitzer relays, Cooper Form 6s. We got all kinds of things that actually give us a better, safe work environment to work in now. Administrative controls, what is that? That's written rules. And you really look at warning devices, that's covered. And then PPE's last. PPE is the last of 5 topics in a job briefing. How well should everyone plan? Hazards, work practices, special precautions, energy source controls, and PPE. Why is PPE last? It's the last line of defense. I tell people all the time in arc flash, just because you got on arc rated FR clothing don't mean you ain't gonna get burned. It just means you ain't gonna get burned up, okay? Because you'll still have heat transfer and a 2nd degree burn through on an 8 cal shirt. I've seen it many, many times. And then of course hazards is first on that list of 5 things, is because if you don't recognize the hazard, and there's the problem, is admitting that it's a hazard and then recognizing the hazard, 2 different things. There's an issue there. I took this picture right here a while back. Now look closely at that picture, lineman. Look at that, and that's very similar to what Vince did. I called that guy down. I said, "Hey, Bubba, come here." And I walked over. I just walked out of a restaurant. I was in Florida, and they was getting ready to reconductor that 3-phase line right there. So they was framing it out, laying it up. And if you'll look closely, one, he don't even have his rubber gloves on or sleeves. Of course, we'll get to that later. And then look at the bare spots. Look at the insulators hanging down. Look at the post insulator on top. Look at right at the end of his bucket, there's a stirrup right there at the end of his jib. I struggle many times with getting folks to understand a bucket is a bucket, but the only part of that bucket right there is tested. The bucket is not tested. The only part, there's a set of arrows right behind that bucket pointing toward the knuckle, and there's a set of arrows at the knuckle pointing toward the bucket. That's tested. Everything else on there is not. Now your liner is tested in your bucket if you've got a liner, because I've got some companies that don't even put liners. They just standing in a fiberglass shell, which is even, to me, is even worse. Matter of fact, I had a fatality because of cover up, and he set the bucket down on a 34.5 phase, and he had his feet right over that fiberglass point, and he touched something different, killed him. I'm not fussing. Don't get me wrong. I'm not fussing at anybody, but I'm trying to relay some information that'll save your life. but there's no path to ground covered up anywhere in that picture right there. And that's what I'm gonna focus on. Now here's another, this is a real, Wayne's out there somewhere. I saw him log in a while ago. But Wayne, this is one of our customers, and Wayne was doing this cover-up program for this company, and he took this picture. Well, when you look at this picture, that's hot over there on that side. Now the other side is de-energized, but he's fixing to build a jumper across that arm, frame it out, put a pin insulator up there, I guess, and frame it out. But let me show you what he did next. Look what he's doing. He's got his left hand on the grounded end of that polymer insulator and eye bolt, and he's got his right hand on a 7620 phase. Now, what are we doing here? Really, what are we doing? He is basically testing his rubber gloves. I mean, yeah, he's got on class 2 gloves, and yeah, but you know, I've been called dummies or worse, but I ain't no good test dummy, okay? I'm not going, the whole thing of prevention of cover-up is to keep you from getting in between two differences of potential, because that's where you're going to get hurt. Well, here's a pole here this is a fatality pole, and it was not too far from where I live in Georgia, south of Atlanta. And contractor working on this pole, young man, 2 years with the company, and he possesses a certificate, high voltage certificate from a vocational technical school. That's a great thing, you know, but that doesn't make you a lineman, okay, because it takes a lot of experience as a master teacher for journeyman linemen. But he got killed on this pole, and I'll show you how he got killed. You see, there's a new switch there and there's an old switch, and he's about to change that switch out. Instead of macking it out and clearing it up, getting it clean to where he can actually work, he hung the new one, and then he was on facing the pole, just like this camera is facing, just like when I took the picture here. Basically, you look at it, and he stuck his hand right through there to tighten up that nut on that arm bracket, and his back of his hand hit that hot 7200 volt switch right there. And he was leaning up against the ground. And he became a fatality. And the problem with that is, see the control basket of the bucket, see his rubber glove right there? He took that glove off because he was having trouble tightening that nut up, and and even the guy in the bucket across from him, there was another junior lineman there, B-class lineman, I think is what they called him. But anyway, he said, I don't believe I take my glove off to do that. And he said, I got it. The last words out of that boy's mouth was, I got it. He's gone. You know, this is what we talk about. And of course, you know, this is why I'm so passionate about cover-up. And then the folks that works with me, sometimes we put these cover-up programs on everywhere because it's the most likely place you're going to get hurt, killed. It's just one of those things to where you just like this gentleman right here, he was in my class, and basically he was the poster child of cover-up. He basically got in the situation about 3 weeks after my class. And in the class we talk about, because of the 2014 standard change, the regulation change, we have to do a proficiency demonstration to say, hey, and then your employer is the only entity that can qualify you as a lineman, not me, not a contractor. I can provide the training and I can do a proficiency demonstration and say, okay, employer, it looks good in the field to me. Now he's got to wave the magic wand over you and make you qualified. So he went out in the field to change out a pole. It was a Thursday afternoon. It came up a thunderstorm. Now this is way down in South Florida, so you got a lot of things going on down there that causes problems. And one of them, you see the bolt-on stirrup up there on that face? He couldn't get that stirrup off, tie that conductor in, on that new post type insulator right there on that pin. And so he decided he was going to do something different. He was going to cut that bolt off with a pair of. When they called me, they said, "Danny, we've had a hot line bolt cutter fail." I said, "A hot line bolt cutter?" Well, I mean, you know, I've done sticks before and transmission, done a bunch of different stuff. I said, "A hot line bolt cutter is 54 inches long with a ratchet handle on it. I mean, tell me what happened." "Oh no, this is an 18-inch pair of bolt cutters." So he got up there and he tried to do it this way and he couldn't. So he puts the bolt cutter handle here, does this, and this elbow got into that pole top pin. It was tracking down his shoulder. And so there you see his right shoulder and his left elbow. Now, by all rights, you know, it should have killed him, but it didn't. The Lord looked after him that day. I told him, I said, "Got something else for you to do, son. I don't know what it is." But he went back out and went to work again. And like I say, the last person I know that got killed that was my friend at Georgia Power was a 37-year troubleman, and he got killed on 120 volts. So whether it's secondary or primary, it doesn't matter. We'll get to those numbers in a minute. Now, another thing too is this is the bottom of his bucket. Now, I climbed up on that bucket and took a picture down, and that's the bottom of his bucket. And the thunderstorm had come up. He didn't even cover the bucket up. It just filled it up with water. It had 2 inches of water in the bottom of it. And I said, "Well, did you slip? Is that what you just lost? You knew you shouldn't touch that, but did you slip?" He said, "I don't know." And that's usually the common answer, because in a very traumatic event like that, it's not uncommon to forget what happened, because you don't want to remember what happened. Is basically what it amounts to. But this is an indication. If what's missing on the pole? Ain't a bit of cover up. There's no cover whatsoever. And he was going to try to cut that thing off and tie that thing in on that new insulator, and no cover. Okay, I rest my case. I'll quit fussing now. Let's look at some history. And I'll just use, you know, historical information. Folks like Jerry Wester and Wayne Harden and a bunch of folks did some history, and we, at our training center in Georgia Power, Klondike, and we came up with we surmised a few things, just practical applications. If I'm climbing a pole, and of course back in the day, I worked 4 kV standing on a pole. So, you know, where's the danger if I'm standing on a pole? So where is the danger? Well, it's the energized conductors on the pole, obviously. So where should we focus our cover and protective gear? And that's on that. You know, you start at the bottom and work up, start in the middle and work out. That's when you're standing on a pole. You ain't got any options there. You gotta do what you gotta do. Now, your position is really important as far as positioning yourself away from conductors, energized conductors, and even covered differences of potential. I mean, cover is rated cover for the most part. A lot of companies, especially my cooperatives, because of federated insurance, we basically we test the guts, but a lot of companies don't test the guts. Well, what's the ground? Everything's the ground. Everything that's not energized is the ground. You think about this, including me. So if I position myself on a pole, standing on a pole, gloving 4 kV, and I don't have everything around me covered up in a correct manner, you know, I can be careful. I can learn to do line work. Yeah, I can do that. But I can also get in trouble. I can have one slip, one unanticipated move, whatever, and I could be up the creek. Now I went back into our archives and I found some pictures, and just for illustration, just like I say, don't take my word for it. But you see there, now you can tell there's a dead giveaway about the timeline of that. If you look at the hats they had on their head, nobody had a hard hat Nobody wore hard hats in our industry until EEI, Edison Electric Institute, did some testing and whatnot, and head contacts were a big thing on 4 kV. So about 1962, 3 or 4, somewhere along in there, and I know I went to work in 67. I wish I still had that old turtle shell hard hat, but it was a hard hat. And they'd been wearing them about 3 years, but you see there that nobody has a hard hat on. But they're changing out that pole. They floated out that field side phase over there, and now then they're untying the roadside phase and fixing to set it off. But you don't see, look at the secondaries underneath, and there's probably an arc circuit right there, street light circuit too. There's usually secondaries, but look how good they covered that up. You know why they covered that up? Because their legs are right next to it. That was the reason, okay? Well, they didn't pay a lot of attention to grounds or differences of potential, because they are the difference of potential when you're doing work like this. Here's another picture I found. It's an old 4 kV transformer, and you can tell that by looking at the arrestor up there. It's a 4 kV glass arrestor. And you see they got the secondaries covered up, they got the bus covered up on the pole, they got the primary kind of halfway covered up top. But do they have any kind of protection covered up right there on the arm? No. Well, along came aerial devices, and that may be my first ladder truck right there, I don't remember. But when aerial devices and insulated buckets came along, what changed in the industry besides our feet quit hurting, standing on a pole all day long? So, you got to looking at it. So when you got this bucket come in, and I know when I was a helper on a line crew, had 3 linemen, an apprentice, a truck driver, and me, and the foreman. We had on the line truck, and then we sometimes had 1 bucket, and that was in 1967. And nobody really thought about this until we, Jerry and Wayne, a bunch of them, David McQuaig, a bunch of them did research. There was no on-the-job training for gloving out of an aerial device versus gloving out of or off of a pole. There was no schools. We just transferred working from the pole practices right into a bucket truck is what we did. We said, cover up the energize and position yourself away from the cover. That's exactly what happened. That's all it was, is just stay away. Here's some other pictures. Even after we started doing a little bucket work, you can see they're doing 4 kV off a pole right there, an old Holland bucket right there with that round green boom on it. And, but you don't see any cover on grounds. Here's a couple more. They're cutting in some underslung knife blade switches. They got faces covered up, but there's no path to ground covered up. And 2 buckets up there. So, dielectric platform or aerial device. And then of course, you don't answer this, not unless you want to be embarrassed. See whose hand went up first? You ever been buzzed standing in a bucket truck and not have something covered up and actually touch something, at primary voltage? And I did it 1 time. I can show you the pole that I did it on right now in Macon, Georgia. Nobody had to ever tell me again about proper cover up. They did too, because we focused on something, and I'm going to show you what the industry focuses on now, I think. And that may be one of our problems that we have to overcome to beat this thing. Well, how come, were you injured because you got buzzed? No. Why? Because you acid tested the liner. Thank God for the liner being acid tested. Now, on the other hand, if you don't have a liner in there, like I mentioned earlier, some of them just have fiberglass holes that they're standing in. That is a work platform, not insulated. So just remember that. So you from a bucket truck, what's really important and how? That's what I want to focus on right now. What can you do in a bucket you can't do from a pole? You can put yourself in positions in the work area that you could never get into standing on a pole. And you can get yourself in Are you at ground potential in that bucket? No, you're insulated and isolated, okay? You're insulated from ground and you're isolated from all things around you, is all it amounts to. So if I get in between two different potentials standing in that bucket, and it's very easy to do when you start maneuvering around on a pole if you don't have it covered up. You know, you're just gonna be careful. Is that, oh, that's what I heard somebody say, I thought. The major difference right there, and here's my story, okay? We had a lot of fatalities, and 92 of those fatalities at my company were on voltage of some kind. Okay, this was from 1926 to 1996, I think, is where these numbers ran, about 70 years. So, face-to-face contacts, none. Well, that kind of got everybody's attention at the training center. I was in safety when all this was going on, and the rest of them, you know, the trainers, we had our training program, and what was our training program based on? It was the regulation. Well, the regulation came out in '94. We already had a pretty good safety program and a cover-up program that had been developed in company for years. Well, phased ground contacts, 91 of the 92. One got in series. He jumped out of a set of bales where, that's another story. Jackie Dawson killed him, Mount Vernon, Georgia, 1971, I think it was. But 91 phased to ground. Now then, that ought to, you know, that ought to get your attention. I'd like to think it would, you know. Phase to ground contacts is more than half of all the other fatalities at the company, and that's falls and car wrecks and everything. That was my in memory poster when I was working there. There 168 names on that poster. There's about 30 something. I went to work in June of '67, and from that point on till I retired in 2007-8, and not a lot's happened since then either, thank goodness. And it's because of a redesigned cover-up program. And I'm going to elaborate on that along with what I've learned in the industry too. But basically, the company identified, the trainers identified what was wrong. And it all goes back to those numbers. The reality is, because of those face-to-ground contacts, you know, we changed the cover-up program at my company, and I am convinced that we may have prevented a lot of accidents just by virtue of going around the country doing this, and I'd like to think so. But I love to share the story. But since we changed the program, nothing's happened in 27 years because of cover-up. We had never gone more than 3 years and 10 months without a fatality, and I remember Hurricane Hugo, and we had 2 fatalities in a week, and it was because of cover-up. And you know, that's the most heartbreaking thing in the world. So, you know, once we figured out what was wrong, we analyzed it. We did a root cause analysis on just about everything there, and we came up with a common denominator of why these things were happening. Because, you know, our program had been patterned after and met what we felt like was the regulation. And I'm going to read you the regulation here in just a minute, and you'll see what I'm talking about. Once we did all this, and we assessed the gloving and practices program that we were currently providing, the focus on training, the standard required, that's all it was. We focused on the standard, what the standard said. But yet that was not enough, and that's the problem. Everything in the work area was not covered as good, and what we figured out is neutrals, grounds, and anything of a difference potential to what was being worked on were not covered. So that allowed us to get in bucket trucks and get in between 2 differences of potential, a poorly covered or non-covered, energized, and a difference of potential. That's all it takes. Now I hear a lot of conversations about wood arms and fiberglass arms and blah, blah, blah. There's no dielectric, you know, that's a difference of potential, and that's the thing you gotta really understand. It don't have to be a dead ground to kill you. It's just gotta be If you maintain in the work area the same potential or cover up the energized and differences of potential, if you can't have current flow, you can have all the voltage in that you want. But if you can't have current flow unless you have two differences of potential. As simple as that. So here's what the standard said. I'm gonna go through this pretty quick because I don't want to, I asked Brent, I said, how much time have I got? And I said, I need 4 hours. And he said, no, you ain't got that much. I said, no, I want to hit what I feel like are some of the most important points about this. You remember I told you we were focusing, our program was focusing on what the standard said. Well, lo and behold, in 1994, when the Code of Federal Regulations came out for 1910-269, it, pretty much said what you're about to read here. The only things that were really changed in here were the employer must demonstrate or the employer must insure or whatever. It was reworded because it felt like the regulation was written pointed toward the employee, but who's responsible for the employee? It's the employer. So it now states the employer must make sure this stuff is happening. Let's look and see what it says. Working on or near energized parts, and that applies to anybody that's working when the hazard's present. Only qualified, and that's A2, 269 A2 qualified employees may work on energized. Now you see I've got energized highlighted, bolded, and underlined. There's a reason for that. We'll get to that in a minute. Well, we go on to say only qualified employees may work in areas containing unguarded energized parts. Okay, well you got to have it unguarded to work on it. Okay, but it don't elaborate on what else needs to be covered up around you. See, and there's a problem. But you got to remember, there's only one regulation for every utility company, contractor, municipal, co-op, it doesn't matter. We all do the same work. So there's one regulation for all the different company or the different types of systems that we're working on. And you notice there's no voltage mentioned here either. It's all the same. Electric lines and equipment shall be considered and treated as energized. Oh boy, here we go again. In accordance with this, unless it's been, D, which is generation, and paragraph M, which is de-energizing for the protection of the employee. Now also, there's a requirement in here that I'll jump guns just for a second. We're gonna get back to the energized part in a minute. At least 2 employees need to be present when things are going on, okay? The types of work. That's installation, removal, and repair of energized parts over 600 volts, okay? Or installation, removal, of repair of de-energized parts if it's subject to be energized by something else above 600 volts. Installation, removal, or repair of equipment such as transformers, capacitors, now we're in substation, okay, with parts of more than 600 volts. Yep, okay, good deal. And then also work involving the use of mechanical equipment. I've had 2 or 3 times. Matter of fact, the first fatality that occurred in Georgia this year, and I think it was the first one I had an account for. I know it was in 22 because it happened to a contractor in Miami working on FP&L, stuck a boom into a 14-4 primary. Now then, this year in January, almost the same date, I think it's 10th and the 12th, I think, they had a 46 kV. There was a contractor setting a pole in a distribution line, but it was near a 46 kV, and I don't have any pictures or anything of it. I just know what I was told. But anyway, something happened to that line truck. They lost control of the boom, and the boom got into, guess what? An uncovered primary. It was an uncovered 46 kV transmission primary. Well, you could have covered it up. We got cover up for 46 kV. Cover up is not meant to be rubbed on or rubbed or fall against or anything else. It's incidental brush contact by a qualified person or equipment. But anyway, so here we go. Work involving these mechanical equipment. That's another thing. So, you know, this year and then back in 22, the first 2 fatalities, we start off the first of the year, every year saying target 0. We're not going to do anything to hurt anybody this year. Ain't 2 weeks gone by and we already had a fatality. Boom. Other work that exposes the employee to the same hazards that we just got through talking about. So that's when you gotta have the two employees present. And a lot of people say, well, Danny, what's the second person for? What's the second qualified employee for? Well, it's rescue. It's first aid CPR. I think there's a misconception out there on the intent of the standard versus the belief, okay, that second person is there to work. But no, they're there to, in case something happens and goes wrong, to get the one that's in trouble out, okay? Rescue, lower control bucket rescue, whatever it takes. Well, contrary to what we just talked about, now I don't need the second person if I'm doing routine circuit switching when the employer can demonstrate that the conditions of the site allow safe performance of this work. In other words, I can maintain minimum approach distance. That's what it amounts to. I do not expose an exposed part of my body to an exposed energized part greater than, with voltage. All right. Also, when work is performed with live line tools, well, there we go. You can't cheat on live line tools. I could tell you 1,000 stories. I was in a place, I won't tell you where it was at, but I got to tell you this story. It's really funny. It's not funny because a guy got hurt, he got burned. And I was doing a leadership presentation, I believe. And of course, I got into a certain part of that presentation and made a comment. And then one of the linemen, he stuck his hand up. And of course, when I'm there with you, I get to talk with you. I said, he says, you know, and this is what he told me, you're talking to the best lineman in the United States. I said, my God, I've been looking everywhere for you. Where have you been? And I asked him, I said, well, let me ask you a question. I said, what makes you the best lineman? It takes 7.5 years for me to make journeyman lineman from in the door. I said, well, dang, son, it takes everybody else about 4. I said, and then we talked a little bit more, and then I told him, I said, well, when was the last time something happened to one of your linemen? He said, yesterday. I said, holy moly. I said, what happened? He said, I had a flash, and it was UCD. I don't know if anybody has. Underground commercial distribution. They put transformers in holes, manholes, and open doors, and the elbows and all was on top of the transformers. I had some in Macon. I said, well, what happened? He said, well, one of them was switching and he pulled an elbow off and it fell and flashed and burned him with a 4-foot shotgun stick. Think about that for a minute. You choke up on a 4-foot shotgun stick, is your hand basically, never mind. You see what I'm talking about? It's whatever works in a lot of places. And then this last one goes without saying, and it's a controversial point too. I've heard different opinions on this. Emergency repairs to the extent necessary to safeguard the general public. Well, what is the general public? Safeguard. When you're reading regulations, you got to look for keywords and phrases because there's some intent right there. And that is that the hospital in trouble that if I'm out there by myself, can I get to drag that primary out of the street with a shotgun stick and maintain minimum approach and not have it locked out, tagged out, clearanced and grounded? No, well, yeah. Well, anyway, that is the 3 exceptions to the 2-person rule, okay? So let's go back in and talk about minimum approaches a little bit because we talked a little bit about that. You have alternative tables, in the new standard in 14, because when it come out in 94, OSHA had, I guess it was kind of an unspoken requirement. This is what your minimum approach distance is. If it's 15 kV or less, it was 2 foot 1 inch, 25 inches. Well, guess what? They said, no, that minimum approach distance will change, especially on transmission because of TOVs, transient overvoltages. There's a lot of things that goes on out there that will change that minimum approach table. You, the employer, shall tell the employee what that minimum approach table is. So they put out an alternative table, 6 and 7, for distribution and transmission. And there's AC systems, DC systems. There's a lot of different stuff out there, okay? So it's really up to the employer to tell us what our minimum approach distance is. And that's one of the, host employer information sharing, A4, 269A, 3 and 4, that they put in the standard, never was there, that basically contractors complained many times that the host employer wouldn't give them all the information they needed. So, okay, well, if he don't tell you, then here's what you got to go by. So there's that. That's why that was put in there. It's what my understanding is. All right, let's go back and finish reading the energized parts again, just to be sure you understand what the point I'm trying to make. The employer shall ensure that no employee approaches or takes a conductive object closer to exposed energized parts. That's extended reach, and that's a bunch of different requirements, and we'll talk a little bit about some of them in a minute. The employee is insulated from the energized part. Now, what you're seeing up here is the standard right out of the code book. So, this is not my words. This is OSHA's words after Mr. Wallace went back and, he did the first one. And back in '71, he did the construction of the transmission and distribution in '74. They told us how to build it, and in '94 they told us how to operate it. So there was a 20-year gap we were in there that we were kind of on our own when it come to the actual operation of a system. And in 20 years later, they updated and combined both of the construction and the general industry, and then that way there was not any confusion. So now then it says, the employee is insulated from energized part with rubber gloves, sleeves, whatever, and the L4 of this, and you see, is from the energized part upon which the employee is working, okay, in a manner sufficient to prevent exposure to uninsulated portions of the employee's body. So, that's the part that's not covered in a rubber glove or sleeve. Look at that conjunctive word at the bottom, or, okay? Or the energized part is insulated from the employee. You wouldn't believe how many times I hear of when companies allow their employees to cover up energized phases and then take the rubber gloves off to work on the pole, just all over the cover. And I'm going, golly, but that's what the standard says. There it is. Or the employee is insulated from other exposed conductive objects in accordance with the requirement. And that's live line bare hand. We're not doing live line bare hand on distribution. Simple as that. So when the employee uses rubber insulating gloves and insulation as insulation from energized parts under this provision, the employer shall ensure that the employee also uses rubber insulating sleeves. Well, here's another one of those points that I run into all the time. Like I said, wherever you're at, everybody has a different opinion. And of course, that one there kind of opened the door. My company, I never wore sleeves because of our cover-up program. And I'd say 50%, maybe 50-50, wear sleeves, 50-50, don't wear sleeves. And that's a choice at the employer. However, here's what the standard says, and I've testified in court suits about this right here. It's amazing. If the employee need not use rubber insulating sleeves if exposed energized parts on which the employee is working on are insulated from the employee, and when installing the insulation, they install it from a position where his or her upper arm is not in contact with energized parts. Well, if you go back and look, and there's maybe one more in here. Yeah, there's one more. When the employee uses rubber insulate sleeve insulation for this part of the, to meet this paragraph right here, the employer shall ensure that the employee doesn't take them off and doesn't put them on within minimum approach. It used to, that changed from the 94. It used to say you couldn't touch the energized part. Now it says there's a magic 360-degree circle around that energized part that you can't puncture it. You can't reach into it. That was an effort there by all of the preamble. That was kind of a negotiated point in the committees of all up front, that they would say, okay, you know, if you do that and you don't take them off, is right here, doesn't remove them, you know, that'll keep you from getting involved in stuff. Well, guess what? It's not. I mean, if you look and see what's going on, unfortunately out there today, you know, because we're humans and we're subject to make mistakes and have forgetfulness or whatever, things happen to us, and that's just the way, that's what happens. Well, lastly here, talk about the employer shall ensure that each employee, to the extent of his safety-related conditions at the work site, permit a position that won't let a slip or fall get into an energized part. And then lastly here, when performs this work on the energized part greater than 600, and then he goes on to give you some more. But you notice how many times energized has been bolded? It has been bolded 9 or 10 times. Why? And I try to be the why guy. The why behind the what is kind of what my motto and philosophy is. I know what to do. I got to cover up. But why am I got to cover up the way I'm covering up? And it's because my employer told me so, or it's because the regulation says so, or is it the best thing I can do for myself to make sure I go home every day? And that's a combination of all three of those. But the last one being the most important, because nobody cares any more about you than you and your family, okay? Because you don't want nobody to get hurt, period, ever. There's no reason to do that. I had one flash, one time. I had been a lineman a year, and myself and a friend of mine named Gene Conger had just cut in a set of 1200 amp gang switches on 795, and basically we just finished that job. Everything went smooth as silk. Cut them in, adjusted the switches, took mechanicals down, and was fixing to leave, and they called and said, on your way in, I got a run by for you. Well, all we had to do was take slack out of a 3-phase pull-off that rolled from flat to vertical. And they had let the guys get away from them, but whatever, it wasn't guying the pole correctly. The pole leaned a little bit, and all of a sudden wind blow, and then all of a sudden, you know, it was a very short span. It probably wasn't 20 feet from the mainline pole to the dead end pole to where it took off. So it slack span just about 20 feet. But you couldn't cover it up, you couldn't do nothing. The only thing I could cover up was the post type insulator that the slack span insulator was sitting on a steel arm. And so we talked about it, and Gene and I, that was a long time before we had OSHA, before we had whatever, you know. But we had come up with a plan. I said, Gene, if you will, I will slack off the nuts in that slack span clamp. If you will hold it, because we can't cover it. I don't want it to flop into a face and have a flash right in our face. And I said, that way we can slide it through there. About 4 inches is all we really need, and tighten it back up. Well, everything went really well till I stuck that wrench up there and was gonna slack that nut off. And what I didn't do is that blanket overlapped, but it left the point of that steel arm coming out in between the split. And my wrench hit that steel arm, and little did I know that every who framed that pole let the pole ground get under the gain of that steel arm, and then it was just like sticking it to neutral. It blew the world up. I was 4 spans from the substation. They told me later it was 8,000 amps of fault current, about 8 cal arc, and it just ruined my day. After we had such a great job, just the letdown we just said, well, we got this day made, and then we went off around the corner and almost blew ourselves up, and it's because of cover-up. And that's my one flash that I had that I created myself. I've been in the presence of several other flashes, but still, you don't want to be around any of them. Well, enough of that. Enough history and enough regulations. Let's just get it really into the meat and potatoes here. Cover-up rules. What should they look like? Gloving safety rules. I mean, when you really look at it, you know, here's what suggestions. Select and maintain a position, okay, you know, that you can properly cover up the conductors and equipment and perform the task with maximum protection. Now, it kind of reminds me of some of those episodes where those people didn't cover up and said, well, I know line work and I got this, I can handle this, but they didn't. And then some did. And that's the really interesting thing, is that you can do this work and not cover up. You can do it and nothing will happen to you if you're extremely careful and you're talented. I don't want to take that away from anybody. But all it takes is one moment, one lapse of judgment, one something to change the whole thing, change the whole outcome. Basically, when you're doing this, it's really important that you avoid, with energized conductors, cables, everything else, position yourself taken that you can't get in between those differences of potential. So after all this time, I came up with Danny's elbow rule. That is not a regulation. There's no code, no CFR after this right here. This is common sense, okay? And let me tell you how I came up with this. You'll see a picture in a minute, I think. But basically, if I have proper positioning, my work ought to be here. It don't need to be down here where it's comfortable on my shoulders. It needs to be here. I need to be right here. If it's below your chin, you know, you're in the wrong position. Simple. But if I put my hands on energized conductors, whether I got sleeves ain't got nothing to do with cover up. Sleeves is an extra tool to put on while you're covering up at the very least. Okay, that gives you additional protection for that unanticipated move or slip. Look at your elbow. If anything around your elbow is a different potential about what you got your hand on, it needs to be covered. Oh, Danny, I don't have time for all that. Yes, you do. Or do you have time to have a flash or a contact? You don't want to do that. Before attempting to do any work around or energized conductors, you inspect it. Make sure everything is in good working order. Abnormalities out there, you know, make sure there's nothing wrong. And take that position. It'll provide you the greatest amount of clearance. Maintain that proper position while you're doing the work. All other equipment, poles and arms of a different potential other than that being worked on must be covered. Like I said, that's not a Code of Federal Relations requirement because they say it energized, energized, energized. And I think that goes all the way back to the 70s, 60s, 70s, and 80s when they started investigating accidents. People were standing on poles and they didn't have the energized parts covered. For the same reason we don't cover them today standing in a bucket. So the emphasis was on energized parts. Only one time in that whole 10 sentences of paragraph L is a difference of potential mentioned. One time. And 10 times energized is mentioned. So that ought to tell you where the emphasis was put, and for whatever reason it was put there. And like I say, a lot of the folks at Klondike come up with this theory, and we agreed. It's because of what working off of 4 kV off a pole is where it came from. Because when all this stuff was being written and researched back then, there was a lot of 4 kV work going on. There's my elbow rule. As I said earlier, at Joseph M. Steele Burn Center, you see his hand's gone. So that's where the ground was at. And his elbow hit an exposed energized part. And that's unfortunate. Yeah, Joseph M. Steele Burn Center in Augusta, Georgia, at Doctors Hospital in Augusta, premier burn center. And they still, I'm sure they still do it. They put on a presentation for IOTA in Atlanta in 2006. And they said if you got a 96% chance of survival if I can get you to the table and start working on you within 8 hours of the incident. And that still holds true today, I believe. And of course, since then, they've expanded the burn center. Now it's got 100 beds in it or more now, where it only used to have about 20. So that just goes to show you the demand of what's going on. And all they do is burns. The doctor's hospital does everything else. The burn center sits over here. Common sense rules. This is just common sense stuff. Set up the equipment where it needs to be set, and then position yourself below the conductor. Okay? It's real simple. Equipment should be set up on the roads in the practical, the least hazard to the driving public and the workers on the ground. Also, now this is paragraph P, which is equipment. 1910-269P regulations require additional protections to be taken when non-dielectric booms, this is digger derrick trucks, boom trucks of some kind, cranes or whatever, is maneuvered in MAD or extended reach of energized parts. And that is the one thing that I see comes up more than often than not in court cases is a dedicated observer. If the operator of that equipment can't maintain good visual distance, in other words, get somebody else in another position to where they can see better and watch that equipment. If they start getting within minimum approach, say, hey, okay, look out. But I wanted to put that in there because anytime I've had court cases that deals with this stuff, I like to use it for examples. Well, here's your alternative table 6 for voltage. You know, they did add avoid contact. What does that mean? 301 to 750 is 1 foot, and 15 kV and less now is 2 feet 2 inches. It used to be 2 feet 1. Anything less than 36 kV, 34.5 is basically what the working distribution voltage is about 31 inches. And the unique thing about this too, and the ironic thing about this is because OSHA regulations are not updated on a routine basis like consensus codes, the IEEE, ASTM, ANSI, all of the other NFPA 70E. Everybody else has got a 3 or a 5 year cycle to where that book is updated because things change. But when OSHA regulations come out, they have to consider everything. The cost of what's going on, the cost of the change, and how it's going to affect the employer, blah, 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 everything. Well, in 2002, the National Electrical Safety Code moved the minimum approach distance to 25 kV to 31 inches. And OSHA did it in 2014. So 12 years later, now what did most companies, you always look at the consensus standard, and that's what National Electrical Safety Code is. If you abide by it, you're probably meeting or exceeding what the OSHA regulations say. So there's your comparison if you like comparisons. Okay? Extended reach. Let me share with you on extended reach, and I'll tell you a couple of stories here. My definition, here's Danny's definition of extended reach. See, Danny's this is me. Any handheld conductive item, tool, or material that is within or may be within minimum approach distance of energized conductor or equipment. Two things to me, some of the court cases that I've had to testify in, or at least offer opinions on and take depositions on, whatnot. One of them was one I had to investigate at my company, a good friend of mine. And of course, you know, it's a case history here, and I'll kind of give you a synopsis. I had a lot of pictures in here, but I chose to take them out in the essence of time. I don't want to drag you through the weeds too long, but there was a time when a cut-in truck was going to go by and tap up a underground service and put it up a pole on a 2-inch shielding. And when the cut-in lineman got, he's by himself now, it's a single contributor, sole contributor. He got out there and he looked at it and said, no, I can't do this, because there's 2 other shields on the pole. One of them had a power in it, and one of them had a telephone cable in it. So there was no room on the pole to put another 2-inch shield in. There was 2 or 3 already on it. So he went and got him some help, came back the next day, and they decided they'd take off the 3-inch shielding with the primaries in it and put this service, 1-aught service in it, feeding this slick box, this telephone box. He said that was the main thing. And he said, okay, well, I'm gonna put this in there. And they took all the shielding down and put it up, and another one showed up, so there was 3 of them. So you had a single contributor that turned into a 3-man crew, and they didn't have a job briefing, didn't do anything. They talked now and made a plan, but it just didn't work out. But anyway, long story short, as they got the wire up the pole, had a lot hanging down, and one of them started putting the shield back up. They had a big hole to get it in there, because there was a 3-phase primary coming out, so it had to do all the hand digging. So one of them was filling up the hole, the other one was putting shielding up. One went and got in a bucket, then the third one, he went and got his ditty box and went over there and sat down on a little brick wall and was terminating a meter base, 122 40-volt meter base. Well, somewhere in that process, they forgot they were a 3-man crew, and the one up the pole had gotten up to the point to where he was attempting to get a measurement, a guesstimate, I call it a guesstimate, of where to cut that excess off. And when he cut that excess off, it flipped right up into a 14-4 switch. At that same time, the injured was over here sitting on the wall skinning the wire to put it in a meter base. Of course, there's a lot of things wrong with that, and everybody can, you know, you can critique it all you want to, but as I said, they turned into a 3-man crew when they were normally working as if they were only one there. But the bottom line was there was no cover up on the pole too. And they could have covered it up and still had the same thing happen. Nothing, you know, nothing. An aw crap would have happened, and that'd been the end of it. But anyway, as it did, it severely injured the gentleman. And of course, he's retired now. Matter of fact, he called me the other day. We talk, and you know, I want to see how he was doing, and he's doing all right. But you could have seen the pictures. I've sat at the Grady Burn Center downtown Atlanta with him, and you want to know why I'm passionate about this? Is because I've seen way too much stuff happen to too many good people. So there's your minimum approach distance. The employer shall. All right, when you see shall in a regulation, what does that mean? No ifs, ands, and buts, okay? When a worker reaches a position of in reach, whether it's extended reach or actually touch in the MAD, okay, then all of a sudden we're in Rome. We got to act like Romans here. You know, start covering things up, okay? Make sure it's all covered up and use the tested, rated equipment it's out there. I mean, we got guts and we got line hoses, we got all kind of stuff, and I'll give you some examples of stuff here in a minute. This is a picture that came from one of my customers and gave it to me, and I think it really tells a story here, because it's a cover-up MAD is a 360-degree bubble around anything that's energized. That's the way that is. Okay, it's not two-dimensional cover. It's not at me and above me, it's below me too. So think about it in that sense of the manner. Everything in that bubble has got to be covered up. when you're working in here, there's some pictures in here that we see linemen doing work. And there's some things I'm going to point out to you when we get into this actual cover up. We're going to do 2 different exercises. One, we're going to change an insulator out on a pole top pin, and then we're going to change out a dead end insulator, polymer glass, in a 3-phase dead end. Okay? So here's some of the pictures of how it should look. Okay? You notice the neutral's covered up, and we'll get to that in just a second. The types of protective cover-up, you got to remember everything is ASTM and ANSI, okay? It's got to be rated at nominal system voltage, which is phase-to-phase voltage by definition, okay? So you've got to do that. Rubber gloves, sleeves, blankets, everything's got to have a test date on it. It's got to be the ASTM required test dates, you know. Everybody, and this is another one of those things, different companies have different procedures and policies. I know some companies that test their gloves every 30 days, and then what does the ASTM standard require is every 6 months. And then of course you'll have everything in between. And then blankets and sleeves are every 12 months. A lot of companies, a lot of employers will actually do that more often than what the ASTM minimums are. These are minimums, so just remember that. Requires minimum dielectric testing. There it is, 6 months for rubber, 6 months for gloves, and then 12 months for sleeves and blankets. So, you know, it doesn't hurt to inspect too. You know, you got to really look for different damages. Check rubber gloves, do an air test on them, and this is what we've always done. But you know, for the last several years now, I've been saying, no, that ain't enough. Fill that rubber glove up with water and put that same pressure on it, roll that cuff up. You might not feel that pinhole with air coming out on your cheek, but if you fill it up with water and water comes out, there's a hole. And there's nothing gonna happen. I mean, that's fine. That's perfectly okay to do that. And I strongly suggest you do that. Also, you got line hoses, you got Salcor guts, and then you got, I think we have some tacos in here, some fiberglass in a little bit. There's a place for all of that. These things are kind of heavy here, 5-foot hoses, you know, and you know, you get a bunch of old number 6 copper that's rotten. You don't want to load it down too bad. You got a break in it or a weak place in it, you could drop a phase. Main thing is joining them together, and that is by couplings, external or molded. Kind of the way I used to do it a long time ago. It's just slide them over one another and lock them. You got a little gap. The thing about this is if you're setting a pole in between some phases and you don't set the phases out and the pole rubs up against that gut, it's going to roll it right off of that other gut right there, and then you're going to have a bare conductor right there in a pole there. So wrap it up with a blanket. If you don't have a coupling, wrap it up with a blanket. That's fine too. Look for the line hoses for damages. You know, a lot of times we'll slide a gut on phase and there might be a squeeze on there, H-frame squeeze on, and you slide it over. Somebody's cut it off and left the steel core sticking up. Well, that's what does it. You know, if you cut a gut 1/3 the thickness of the gut, then now you've derated it. You know, it's either class 3, 4, 3, or 2. And, you know, it depends on, you got to have the standard system, got to be nominal system voltage. So make sure you keep it at nominal. I always say cut it off, the bad part out, and use the short hoses, the good parts of the hose, for, you know, special applications, either jumpers or in between material handling jibs or whatever. Proper storage, you know, just don't ever fold them. If you fold a gut up, I've seen people fold guts up and stick them down in buckets or in the back of the buckets. Flat, keep them flat and keep them straight, because if they lose their mold, you'll never get it back. Okay, that's just the way the world is. A lot of pin insulator hoods and fire hydrants or whatever, you know, gladiator hoods, I've heard it called, you know, I need to write another book on what people call things. across the country because it changes from one place to another. But use them as they are intended. Some of them got large ends in them and some of them have smaller, but don't force one into the other that doesn't work. You know, just don't do that. It's another good application for a short hose if you wind up with something like that. So, pole guards, these are usually class 3 pole guards, 30 kV. They're the best thing since sliced bread. So, you know, I always tell people I like to have all of the security I can have. In other words, if I'm setting phases out to set a pole, I'm pretty good with just rubbering the phases up. But if I'm setting a pole inside 3-phase line that I can't set the phases out or untie it and hold it out or whatever I want to do, I'm going to put these guards, I'm going to put these pole shields on there. And that way, if they'd have had that pole shield on that pole where that derrick got away from that guy, and there was pole shields on that pole, that guy may have been alive today. You know, because he was on the bottom of the pole. Now, the phase wasn't covered up. Did he have rubber gloves on? I don't know. Did he have his knee up against the pole? I don't know. But when he got into that 46, he left this world. Of course, here's your tested equipment. Basically, gloves and blankets, and there's your sleeves. So that's got to be tested according to ASTM. It's got to be marked accordingly. Blankets, you know, attaching the blankets, basically don't use tape. First thing this morning, I saw when I got up and I got my phone and went to LinkedIn, and I saw Brent's message. But the first thing I saw was a Klondike pen. It was being advertised by Jay Matthews. And that Klondike, big old blue pen, about that long, and he was advertising to go on transmission poles to hold blankets on there rather than, you know, people use P-lines or Velcro or whatever it takes. But that pole Klondike pen, and I never forget, there's a fellow named Danny Anderson that worked at Georgia Power Design. That thing you see up at the top up there, just a regular pen with a little PVC on it and a spring. He's using that on a distribution pole, and somebody saw it, and the next thing you know, they're making them and selling them for about $80 a pop. So anyway, it's the best thing in the world, though. It's called a Klondike pen. You can use that. You don't have to use, on the underground, use the magnets and the buttons, but just don't use tape. You'll see some, I think I've got some pictures of some tape stuff, and it's not good. The adhesive on the tape will make the blanket fail eventually. Proper storage of the blankets, hang them, roll them, one or the other. Don't do anything different than that. Of course, there's your gloves, testing the gloves, and of course you see this slide here. I didn't change the dates on it. It says do not use after 76 days. That company will test their gloves every 60 days, and then they give you about a 2-week window to get them transferred back and forth to get them replaced. And then the date, I like expiration dates on gloves instead of test dates because I have to think on test dates and know my months. Depends on what it is, but also, you know, if you could get your tester to test to give an expiration date on it, and then that way it would make it a lot easier. You know, it's just a suggestion is all it is. Of course, the right kind of glove is the right kind of application, and of course everything is nominal system voltage, which is phase-to-phase voltage. The only exception to this nominal system voltage requirement is that we can redefine what nominal system voltage is if we have good cover-up. If I have a 3-phase line, multi-phase exposure, and I got 2 of the 3-phase conductors covered properly, then I can actually glove one less category down. In other words, there's a lot of companies right now, many companies will glove 14.4 with class 2 gloves. But so if I'm gloving 14.4 17 kV, it's fine. But I cannot go face to face, God forbid for that. But why would anybody do that? Well, again, last thing I want to mention on gloves is tapered sleeves versus straight sleeves. And the tapered ones work good because it doesn't curl up in your arm. And of course the straight cuffs do, but you don't, the glove cover is the main thing you don't want to do. You don't want to put the wrong glove cover on there because you reduce the tracking distance then on your leather protector to your grommet on your sleeve, your rubber glove. So if you don't wear sleeves and you don't tuck them in like you're supposed to, that's another story. You know, just you use the right glove cover. There's your rated equipment. Here's a class 4, 36 kV. And I found a 72 kV spiral conductor. Like if it had one of those on that 46 line, that never would have happened. That fatality, I don't believe. That and shields on the pole, I don't believe it had ever happened. A little bit about live line tools here. We talk about the design of live line tools, rods and tubes. It's got a standard. You got to test them at least every 2 years. Take them out of service, inspect and clean, and test. The manufacturer's performance standard is 100,000 volts a foot for 5 minutes. The retest on it, whatever the employer can do, or say it's just as good as a 75,000 volt test for 1 minute. So, and that's the difference, and that is in the ASTM 711, you know, the fiberglass stick testing, okay? And you can see it even has a reference to wood out there in case somebody still has wooden sticks, and I hadn't found any long time, but there's a reference to it in the standard itself. The live line tools here used for primary protection. That's another thing that I want to mention. What does that mean? Live line tools used for primary employee protection shall be removed, okay? A lot of companies will say, well, we got to wear rubber gloves using sticks. Well, according to that, if it's tested and approved and inspected, and of course, the one thing that probably is a miss more than anything is I'm going to show you the most violated regulation, I believe, in any of the 1910-269 standard in just a second, okay? And there it is. Each tooth should be thoroughly examined for defects, and when it's taken out, and then it will be reconditioned if needed, and treated, waxed, cleaned, tested, and put back in service. The one standard, the one regulation is that it shall be wiped down every day. In other words, don't pull that shotgun stick out of the box and just hang it on the bucket and tell them to go do whatever they're going to do without wiping it down, because that's in the standard, that's in the regulation, okay? Well, only qualified employees may work on exposed nearest parts. That's what we're about to get into now, is working on these exposed live parts, okay? And we've talked a little bit about this already. Equipment to be energized and treated the way it should be, all right? So now let's cover something up. This is a little animation right here that I found that I like. Now I know this doesn't fit everybody's bill because neutrals are not always at 7-foot specs. Some of them are about 12 inches underneath the arm braces. But anyway, the theory and the philosophy is the same. Cover up the first current carrying conductor you come to on a pole. If I'm going up in a bucket truck, or if I'm going up climbing a pole, then cover up the neutral, okay? And then I'm gonna cover that part of it up. Now then, I've covered up the first current carrying conductor. That's some of my greatest pushback on this program right here, is why do I need to cover up the neutral? I'm gonna be above it. Well, because it's the neutral, it's a current carrying conductor. Then I start, if my bucket is set up in this quarter right here, I'm gonna boom up, I'm gonna put 2 guts. You notice I put 2 guts on each phase conductor? And that's because you only have a gut's only 5 feet long. And if you go in at the proper angle, you know, you may be okay. But if you go in at an acute angle, you're gonna have a hot phase right by your shoulder right here if you're not careful. Well, the one thing that was changed at my company when we did the root cause analysis, we decided, you know, the training department decided that it was not being covered up the way we should cover it up. In other words, the sequence of actually installing the cover. And that is cover up all the energized first. And this didn't have pin insulator hoods, they had blankets, which is okay. So now then all my energized parts is covered up before I ever cover up a ground or a difference of potential. But now then, I'm ready to start covering up, say what I'm going to do on the arm or whatever, and you can see here. Now, I'm sure I just raised a question here. What if I'm not just going to work on this roadside phase right here? I'm not even going to go over to that side of the arm. Well, don't cover it up. You're 8-10 feet away from it. But I am going to cover up B phase. I'm going to cover up A phase on the road, and I'm going to cover up B phase, and I'm going to cover up all of that and that arm and everything else before I ever start. And I won't go, if I'm not going to go over to that side of the pole over there, I'm not going to cover that pole. I don't want to turn it to orange. I don't want to make a rubber tree out of it. And again, too, as I said earlier, if you have the tacos or the fiberglass, they're about 50% of the weight of that of a sow core, rubber eel blanket, a rubber gut. Well, some people have a Hendrix cable, and I think Wayne and I went to Boston, someplace up there in Massachusetts, north. We did some insulation and cover up and training that we did and that's all they had was Hendrix cables and circuits. So, you know, that was new to us. We'd always been dealing with that. We found out it's probably easier to do with it than it is anywhere else. These are some of the pictures we took up there because, you know, the phase conductors don't have strain on them. The only thing that's got the strain on them is a messenger. So, and whether it's a straight line or a dead end, it don't really matter one way or another. You know, we taught them the cover up class up there just like we would here, and they're using a link stick as we see, and it's just like it's supposed to be. It worked out really good. Now, when you're covering insulators up, this is another thing that can get us in trouble. You know, when you got a metal base on an insulator, if it's a post-type insulator or angle, whatever, clamp type, cover up the middle. Don't leave anything exposed down there. Cover it up like it should be. And even on a pole-type pin, there's a little bit, I'm not a pessimist, I'm an optimist, okay? But if it can, it might. So if you cover it up, it can't. And that's simple as that. So let's look at just changing this pin insulator out right here. This is what we want to do. We're going to start by covering up our neutral, okay? And then the neutral and the first current carrying conductor we come to. Then we're going to start on the A phase on that roadside. He's going to come up and cover it up, and then he's going to reach across and get B phase, and then he's going to come through underneath and cover up C phase. Now, another thing too I want you to point out, and I'd need an arrow. See the blanket on the roadside phase? That's on top of the guts, and that's on there for a purpose, because when you're there, look behind him right there. He's got his back. He's up in between three phases. He's gloving B phase, but he's got his back to be A phase. So that blanket is on there for an additional layer of protection for him while he's up there. If something were to happen to the gut, that blanket's going to protect him. So that's what we're talking about doing. So we're going to change this pin insulator out. Let's go through this fairly quickly. It's pretty simple, really. When you get it all covered up and you put your split blanket on your pole top pin, you come back up and break your rubber, get your material handling jib ready, and put it on there, okay? And then take just a little strain, okay? There's a good place for one of those cut off guts too that we talked about a while ago. You got one damaged, you can't get no 5-foot gut in there because this is a good place for one of those. Then cover up your roller head on your jib, material handling jib. because now you're going to turn your back on it. So now then we go here, split the rubber on our insulator, and then we got our split blanket in place. Then we start untying it, okay? When you get it untied, lift the conductor out of the saddle of the insulator very carefully, watching each span. You'd be surprised how many times flashes occur mid-span when I'm working at the pole, and that's because if B phase goes to the top, you know, for a dead end, but that's fine. But if you're rolling from flat to vertical, then you're going to have a clearance problem mid-span if you start picking up and moving things. So you always want to watch your spans, and don't do anything to get it together in the middle of the span. So when you finally get it up, get it cleared, put the rubber back together, go in. Now you got only one exposure here. You got one potential exposed, and that's your ground. You've covered up all the energized parts. So now then we're going to take that insulator, I-9 insulator off, and then we're going to cover it, reinstall the new one, and then we're going to drop down the phase now. We got the phases split. We're not doing anything on the ground anymore. So now then we're going to split the guts, and then we're going to drop the conductor down and start tying it back in. Put all our rubber back together, because now then, this is another part here that a lot of people, you know, give a little pushback on. But a lot of people will say, golly, Danny, why do you want me to cover it back up? I'm fixing to take it off. Well, that's fine. But now then, you're going to start taking cover off of a ground or a different potential. I want you to cover up the energized while you're doing it. And then when you get that done, you can go in C phase and pull C phase, and then B phase, and then A phase, and that's all done. I can assure you, I know, it looks like a lot. We go to places all the time that don't even have enough cover on the bucket truck to do what we ask them to do. And they say, well, my gosh, we never had that much cover on a bucket. And I said, well, maybe you should. You know, do you really want the assurity of increasing or decreasing the likelihood of something happening to you? Then increase your cover and protection. You know, be sure you secure conductors when they're untied at all times. We used to just throw them out on the arm, put a blanket on it, do whatever we need to do with it. I know I was one of my customers one time. We had this conversation about, well, why don't you put a blanket on the arm? Just throw it out there on the, we don't even put a gut on the face. We just throw it out on the arm. And I said, really? And we were way west. I'll just leave it that. I'm not going to say where I was at. And I said, well, don't try that, you know, east of the Mississippi. I said, we have moisture there. I mean, you don't have a lot out here in the desert. And everything out there, unless it's monsoon season, is very, very dry. So even in Hawaii, this was another one. This is Hawaii Electric in Honolulu. I went over there to do it, and those boys over there was fussing at me because, see, they have double circuits, but they have a lot of their system is on like a 60-foot pole, and they have about a 10-foot separation between the top circuit and the bottom circuit. Well, that's their spec. And he said, what do you want me to cover this up down here for? Because I'm gonna be working up there. And I said, well, gravity works all the time. Something fall from up there to down there, and now you're gonna be in the middle of the fireball. I said, cover it up when you go by it, and you ain't gonna worry about it. It's real simple. Well, removal of the equipment, anytime you put it on, it's, you know, it's last on, first off. It's whatever the last thing you put on should be the first thing that comes off. But you remove it in the order that best protects you while you're there. You know, rubber gloves, proper class, shall be worn the entire time and you're in the energized area. And MAD, you got to be clear of MAD before you can take your rubber gloves off. Just a couple of things to look at right quick, and that is, you know, the way we used to cover up versus the way we should cover up. And that's basically, you know, if you don't have a pin insulator hood, use a blanket. And there's another installation, another gladiator hood there. And these are just some applications. split blanket, split the porcelain insulator, drop it over, and then when you get that covered up, now you can cover up the ground. And that's just an example of keeping one exposure at a time. You know, don't be doing two things at one time. So this is a suspension insulator. This is a polymer, and this is one of Wayne's favorite topics right here is that polymer insulator. That's about 8 skirts on a 14.4, 25 kV nominal system voltage. And a lot of, just like that guy that you saw earlier that put his hand on the grounded end of the polymer with his rubber glove, a lot of people think that polymer is insulated all the way through, but it's not. And it really depends on where it's at too. If it's around salt water or contaminated atmosphere, it's even worse. But it takes about 3 or 4 of those skirts from the energized part for the voltage to fall off to almost nothing. So, you know, that's tracking distance is all that really is. So that's what we're talking about right here. But, you know, if you cover it up completely. You know, button it up, make sure it's done correctly to where, don't leave those gaps. And like I said, I'm not a pessimist. I'm an optimist. But just don't even leave the opportunity for anything to happen. Whether you use blankets, whether you use hoods, and then you can use split blankets like this to cover up grounds while you're working and uncover what you're going to work on. This is a staged picture right here. This is back in the day when some companies decided they could wear short sleeve shirts instead of long sleeve shirts. That's before the standard changed. And of course that's a staged, you know, that's a violation of minimum approach right there. Even with his shoulder, much less his elbow. But it should always cover those roller heads and get them, because they'll be right there at you the whole time. And you're not. Last thing we'll do is cover up and change a dead end insulator, and this was easier. A vertical is much easier to change than a flat one, because you'll see what I'm talking about when we go through this thing. So we start with you know, putting a hand line up there to pull the rubber up and down, and you'll look at these two pictures and you can see we start at the neutral conductor and we get it covered up completely, and then we go to the 3 phases, and you see where he has put a blanket on that, you know, middle face right there, and he's putting a blanket on the top face, so he's got them all covered up. So now then the energized parts are covered up. Now then he's going to cover up the pole. So he's going to get that pole shield, that 30 kV pole shield, class 3 shield, and he's going to start covering it up. And then we'll install a link stick, okay? And the link stick, you know, some people have 12-inch link sticks, some people have 18s. It just depends. I hope I put this picture in here in the right place. But I was doing a cover-up class out in New Mexico not too long ago, and I looked up there and I saw what they had done, and what basically they let the sling come too far out from the pole, and the link stick was compromised to the grounded end of the link stick was compromised to the energized part. Well, that don't do you any good. You know, but like I said, I personally too have been driving down the road and see somebody catch off on an arm with a nylon sling and a set of nylon ratchet hoist and catch a hot face, you know, rather than use a link stick. And I'm going, no, I don't believe I'd do that. You haven't seen that A.B. Chance video, have you? Well, anyway, whenever you get ready, you want to be sure to verify that you see that grounded, you never let that grounded end of that stick get out to the second insulator if you're using 3-phase insulators, or you know, over half the polymer. And then basically then when you put it in place and start to work on it, you cover up all the grounds. Now then I'm ready to uncover the energized part, and now then catch it off with my nylon ratchet hoist, okay? And now then I'm going to catch just enough of the phase conductor out there that I can take the strain off the insulator and put it on the link stick. So now then I've got it, okay? And we got the strain now off of the the dead end, and now then I want to, instead of letting that in, I'm fixing to take it loose. So what am I going to do? So I don't want that thing flopping around. So I want to secure that tail to my strap. So I'm going to take a collar rope and tie it up to my strap to maintain this, constant stability while I'm working right here. Okay, and then I'll cover that up with a blanket. Now then I can change my insulator. And whether it's a polymer or whether it's a glass insulator, it doesn't really matter. Just be careful with the glass because it's got real sharp edges. It can damage your rubber gloves. When you start to change that, disconnect it and then put the new discs up there and then reconnect the dead end to that, the dead end shoe. You see, you still got it tied up with a collar rope, and then just put the strain back on the new insulators and then start taking it down. Cover up the grounds again, and now then you're working on that. And now then when you get this off right here, cover it back up. Now you're going to start taking the cover off the grounds. So you never have, and the key to the whole thing is never have two potentials exposed in the same work area. If I can reach it from one side to the other. So there you are, that's the end of it. Remove the cover in order, start at the top. The last that you put on should be the first that comes off. That'll be that pole shield on that pole right there, and then go up to the top. You got the ground, now then start taking your rubber off and then wind up at the neutral and you're done. I do want to mention a jumper holder, and I know I see a lot of people still doing this, and I used to do it because I didn't have a jumper holder. But where are you going to put the mechanical jumper? I'm up there by myself and I got to jump out a phase conductor. So what am I going to do? I'm going to put one end hot. Now I got this thing's hot as a pistol ball in my hand. Where am I going to put it while I move the bucket over to where I need it? Am I going to hold it and move it, or what am I going to do? I've seen people stick it down in the control cabinet. I saw them stick it in the bucket one time with me, and I said, no, I don't want that in the bucket with me. No, don't do that. Then go back and put your other end of the mechanical jumper where you want it on the face conductor, and then come back. And then all you got to do then when it's on that jumper holder is just move it about 6 inches, 8 inches from the jumper holder to the conductor. So now you're in total control the whole time, and there's nothing, you can't get in trouble. The main points out of all we've said today is cover and uncover in the order that provides the greatest clearance. Bottom to top and outside to middle. Depends on whether you're, in a bucket or on the pole. Use nylon slings, link sticks on the pole to maintain that insulated value between the energized part and the ground, or difference potential. Watch the mid-span clearances when you're doing it. This is Jim Vaughn. I'm gonna blame this on Jim Vaughn right here. He put this picture in IP magazine, I don't know, it's 10 years ago, I guess. And I think his phone blew up. He said, well, if you don't cover up, we're gonna cover you up. Put you in a 40 cal flash suit, sleeves and gloves. And nobody's gonna want that, I don't think, before it's all said and done. Just a couple of facts and I'm gonna close right quick. But let me tell you something. This is Danny again. This is a NIOSH research that they did. Said a lot of things happen on 15 to 25 kV. And they said, well, it happens because the NESC spacing, well, it's close. I mean, I'm looking at a wood arm up there right now, and you probably have 31, 32 inches in between the face conductors from the end of the arm to the pole top end, okay? That's what's right here in front of this tent that I'm in. Well, yeah, but that's what cover's for, okay? When you get in those positions, cover the differences of potential up for sure. But here's what happened. This is what their conclusion was. Well, the report concluded that for almost every electrical accident, there's an explanation for this cause. And I disagree with this explanation. The worker forgot his safe work rules and failed to use rubber gloves and rubber cover-up. I have a problem believing that you forget to cover up. I can tell you now, I glove primaries from 4, 12, and 25 kV as a lineman, and I never forgot to cover up. It's just that what did I choose to cover up? That's the missing link. And that's my overestimation of my ability to control that situation or whatever it was. But fortunately, that one flash is all I ever had that I caused. And from that point on, I had a completely, totally different respect for cover-up. Here's another study, EPRI, Electric Power Research, 10 years. They checked in here and said, although, here's the key, utility line workers typically receive extensive training in electrical safety and the hazards associated with electrical energy, they had the highest number of fatal injuries. And they had some statistics in here. Line worker fatalities were due to failure to utilize required personal protective equipment, gloves, sleeves, mats, and blankets. Ladies and gentlemen out there, and I'll tell you what, I've thoroughly enjoyed my time with you this morning, and I'm fixing to close. But let me tell you something. There is no excuse that I can come up with personally for you not to take the time to cover up. If you need cover, tell your supervisors. I don't know of any company that says, no, I ain't gonna buy you no more cover up. I just don't believe that. I just don't. What it is, we just don't ask for it, okay? It's just whether it's a matter of convenience or whatever it is. And there's one of the last pictures that I'll show you, and this is what I want to leave you with. This is because he didn't cover up. And he took his gloves off and he got in between two different points of potential. That's 7,200 volts right there. That's another Joseph M. Steele Burn Center presentation. And he got into two different points. He had an entry on his left arm and an exit right there on his right shoulder and his right hand. Of course, that result of that, he lost both arms. Didn't even have a prosthesis. He couldn't even put a. Nobody needs to suffer that pain and that agony and lose that quality of life. I just really feel so sorry for people when I see them now in court cases and all, to where they've actually, got into trouble, and it was just a matter of choice, really. I mean, when you look at the picture, you look at the accident reports and everything else, and they didn't cover up, then it's just one of those things. Well, I'm gonna leave it with you there. That's my presentation on distribution cover-up. I hope that we have touched on something, take a couple of nuggets away from here, from this presentation, and you might want to go back and re-watch it again. But thank you so much for your attention. I'd like to personally thank everybody out there that took the time to sit and watch this, and I hope that it's helped you a little bit, and God bless, and take care, and you take care of yourself and all those other people around you. Thank you very much, Brent, for having me.